Good morning, students. Welcome to today's lecture. In the last class, we discussed long division method and remainder theorem method to find remainder whenever we divide a given polynomial by another polynomial. Okay. Today, first I will take a doubt by many of you that why I was changing sign after every step of long division method. Okay, let's see. First, please revise this thing that division is a repeated subtraction. I hope you all knew this thing. It is just like multiplication, which is repeated addition. Okay. Now see. First, I have taken an example 315 divided by 2. Second, I have taken example minus 315 divided by 2. You have to observe what I am doing in every step because you all have been doing this. You all were conditioned to do it like this, but you never saw this process of negative changing like this. So today we will observe it carefully. First, the number digit is 3. So 2 ones are 2. You can see this 2 is positive. So what we do, we multiply it with minus 1 you can say. So it becomes negative. 3 minus 2 is 1. We get 1 also here. Now 2 fives are 10. Again 10 is positive. Multiply it with negative. It becomes negative. So we get 1. Then we get 5. 2 sevens are 14. Again multiply it with negative. It becomes minus 14. And we get 1. This step which I am saying multiply by minus 1. This you were conditioned from your childhood that whatever you write just minus it. I hope you know this thing. Whenever you do division, you just subtract like this. But you never knew it comes from multiplying with minus 1. Okay. So we can write this as 315 is equal to 2 multiplied by 157 plus 1. This is the dividend is equal to divisor into quotient plus remainder. Now, the second example minus 315 divided by 2. Now, first number you can see is minus 3. Here it was plus 3, it is minus 3 over here. So I am multiplying with minus 1. So 2 minus 1 is a minus 2. You can see the number here is minus 2. Now, we all know division is repetitive subtraction. So we multiply again this term by minus 1. As it was earlier minus 2, multiplying with minus 1, it becomes plus 2. That is why I changed the sign at this step. So we have got minus 3 plus 2. It gives us minus 1. This 1 comes here. Now we have minus 11 as dividend. So we will take 2 into this minus is already here. So no need of putting one more minus. So we can take it as 2 into minus 5. It becomes minus 10. Again, we have to multiply this term by minus 1. As it is minus 10 already, it becomes plus 10. So we get minus 1 again. Now this 5 will come. We get minus 15. 2 minus 7 is minus 14. Again, multiply with negative 1, it becomes plus. And hence the answer is minus 1. The issue is you have hardly ever solved such examples where we have a negative dividend. That is why this rule you never knew. Okay, but in polynomials we have used this thing. That is why it was confusing you. Okay, I hope you got this. In case not, please repeat it one more time and you will understand. Okay, no need to write it down. Still, if you want, you can write. Okay, exercise 2.3. This was your homework in the last lecture, sorry, in the last worksheet. So today we'll try to take 2-3 parts of these questions to get a clear picture of these questions, how to solve. Okay, question 1, the question statement is find the remainder when x cube plus 3x square plus 3x plus 1 is divided by, there are 5 parts, I am taking the fifth part, that is 5 plus 2x. Now for the convenience, I have taken the dividend as px and I have taken the divisor as gx. Okay. Now, first I've told you that that worksheet also that you can solve question 1 completely by remainder theorem, and the other two questions you have to do by both the methods. So I'm doing it with remainder theorem, very easy. Step 1 is we take the divisor. In step 1 we take the divisor, that is gx, and we find 0 of gx. How to find 0 of a polynomial? I told you whatever polynomial it is, just put it equal to 0. The same way I have done, that is gx equal to 0. What is gx? It is 5 plus 2x equal to 0. Okay. So we get 2x equal to minus 5, and finally we get x equal to minus 5 upon 2. Okay. So what we have done? We have in the step 1 found 0 of gx, which is our divisor. After finding the 0 of divisor, what will I do is I will put this, or sorry, I will replace this in the dividend to find the remainder. So this is step 2. Now for remainder of px upon gx, we have to find p minus 5 by 2. So you can see what we have to do. We just have to replace minus 5 by 2 in the place of variable, which is x. So you can see question was x cube. So first term is bracket minus 5 by 2 whole cube plus 3 into x square was there. So I have written 3 into minus 5 by 2 whole square plus 3x was there. So I have written 3 into minus 5 by 2 plus 1. Now simply open the cube. It becomes minus 125. 2 cube is 8. 5, sorry, minus 5 square is 25 into 3 is 75. 2 square is 4. Then we have 3 into minus 5 minus 15 upon 2 plus 1. Now what we have done is just taken the LCM. LCM is 8, solved it and got the answer minus 27 upon 8. This is our remainder. I hope you all solved this question very easily. Okay, in case not, please see and write it down. Now I have taken question number 2. I have told you in that worksheet to solve the question number 2 and 3 by both the methods, that is long division as well as that remainder theorem, because this will help you understand the long division method, because many students do mistake because it is little bit tricky to find the question properly. Okay, now let's see. Question statement is find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. So you can see the variable here is x, a is a constant over here. Okay, so don't worry about it, just consider the x, which is a variable. Now method 1 I am taking, that is long division. So my divisor is x minus a, my dividend is this one. Now first see x, the first term of divisor and first term of dividend. It is x cube, it is x. What do you think? We should multiply in x to get x cube. Very easy. If we multiply x square in x, but we will get x cube. That is why the first term I have taken is in the question x square. So we can say x into x square is how much? X cube. Similarly, this is remaining in the divisor. So we'll multiply this also. Minus a into x square is minus a x square. Now we will multiply these two terms by what number, beta? I have told you in the example. Yes, whenever we do division, we multiply this term by minus 1. That is why this was plus, it became minus. This was minus, it became plus. I hope now you are getting the concept. Okay. So you can see these two are exactly same but of different signs. Then that is why we have got a 0 for this as well as this, because they are same having different sign. It is positive, it is negative. So again these two are cancelled. This 6x minus a comes as the new dividend. Now we have to find another term in the question, that is x into that term equal to plus 6x. Just think, what will you multiply in x to get 6x? Very easy, just multiply with 6. So I have taken plus 6 as the next term in the question. Now you can check x 6 are 6x and minus a into 6 is minus 6a. Very easy. Now again multiply this second level by -1. So this is positive, it becomes negative. This is negative, it becomes positive. Now you can see these two are same terms of different sign. So this term will cancel, 0 will come here. And in this case, it is plus 6a and this is minus a. 6a minus a is plus 5a, which is your remainder. Now, as I told you, I will use other method also, that is remainder theorem, which says you have to find 0 of divisor first. So step 1, that is 0 of gx. What is gx? X minus a. So what we'll do, we will put it equal to 0. That is x minus a equal to 0. So x equal to a is the 0 of our divisor. Now step 2 is we will find p of a, that is this number for remainder of the dividend. Now what we have done, wherever x is there we have to put a. Here I have done a mistake. You should always put it in a bracket because everything which comes new should be in a packaging. Okay, so please put a bracket here also. It is a whole bracket cube minus a whole bracket a square plus 6 bracket a minus a. When you solve it, you can check these two will cancel. 6a minus a is 5a. So we have got same remainder by two different methods. Okay, now question number 3 statement is check whether 7 plus 3x is a factor of 3x cube plus 7x. What I've done is I've named the dividend as px and the divisor as gx. Okay, you can name it anything, no issue. Second thing I told you in the last lecture, before starting division, first make sure that the terms are in standard form. Now you will think, what is standard form? Very easy. You have to write the polynomial in decreasing power or descending powers. So you can see here 7 is coming first, then 3x. It is a wrong statement. So we should change their position and write like this, 3x plus 7. Now it is in standard form. So divisor is 3x plus 7. Dividend is 3x cube plus 7x. Now first statement is very easy. What should I multiply in 3x to get 3x cube? Think, what should I multiply in 3x to get 3x cube? Very easy, x square, because 3x into x square will give me 3x cube. Second thing, this will not be left behind. This will also multiply. So we will have 7 into x square as 7x square. Now you must be thinking why I have written it at this position away from here. Why this position is vacant? The problem is this is 7x square and this is 7x. They don't have same degree. What we do in division is we always write same degree terms one above other. So as there was no term of 7x x square, I have written this term at different place. Okay, I hope you got this. Now same procedure, we have to multiply this complete second level by minus 1. This was positive, it becomes negative. This is positive, it also becomes negative. Now same terms, different sign, cancel, 0 will come. Now among these two, what will happen? This is having higher power, so it will come first, minus 7x square plus this term, that is 7x, because it is the standard form that we have to follow. Now you have to think, what should I multiply in 3x to get minus 7x square? This time thinking this thing in mind is little bit tricky. So till the time you can do such multiplications in mind, you can use rough column like this. What I have done, I have written the divisor 3x bracket, the number that I have to think of. It should be equal to how much? Minus 7x square, as I have written over here. Now this number is what? Very simple. Just make it alone on this side like this. So what will happen? This is in multiplication. It comes in division. X and x square. What will happen? X power 2 minus 1. X will remain here and we will have minus 7 by 3. So we can say we have to multiply the given divisor with minus 7 by 3 x. Let's write it over here. So the next term in quotient is minus 7 by 3 x. So 3x into 7 by 3x is how much? Minus 7 by, sorry, minus 7x square. Now 7 into this thing, very simple. 7 sevens are 49 of negative minus 49 upon 3 and x. I hope you got this. Now, as they both are of same power, that is why they are one below other. Here also they have same power, so they are correct. Now, same procedure. Again we multiply this level 2 by minus 1 and you can see what will happen. This was negative, it became positive. This was negative, it became positive. So, same numbers, different sign, we have got 0. And in this case we have 7x plus 49 upon 3x. To show you how to add this, I have done here as a column. Simple. I have taken the LCM. It became 21x plus 49x and the answer is 80 upon 3x. Just like this. After this, you have to think what should I multiply in 3x to get 80 upon 3x. Again, very tough to guess what should we multiply in 3x to get 80 by 3x. So again, I have taken this help of the column. So 3x into something should be equal to how much? 80 upon 3x. So this blank is equal to 80 upon 3. This 3x will come in denominator like this. X and x will cancel. So we will have 80 upon 9. So simple. Third term in the quotient is 80 upon 9. 3x into 80 upon 9 will give us plus 80 upon 3x. Then 7 into 80 is 560 upon 9. Now again in level 2 we multiply with minus 1. So it becomes minus. Same number, different sign, cancel, answer is 0. And the final answer is minus 560 upon 9. Is the remainder 0? No. You can see the constant left is not 0. So we can say as Rx is not equal to 0, therefore Gx is not a factor of Px. I hope you got this. Yes? Okay. Now, next topic is factorization of polynomials. This topic we have done in last class also. It is just an extension of that topic. So before I move to degree 3 polynomials, we must revise what we have done already. Okay. Now, a general definition of this factorization of polynomials is simple. If Px is a polynomial of degree n which is greater than or equal to 1. So you can say degree 1 is possible, that is a linear equation. Degree 2 is possible, that is a quadratic equation. Degree 3 cubic and so on. But it cannot be less than 1 because if you take it less than 1 it will be a constant number. Okay. Now, okay, if Px is a polynomial of degree n greater than or equal to 1 and a is any real number such that when we find P of A, we get 0 as answer. In that case, we can say that x equal to A is 0 of Px. This is what we have been doing till now. Whatever we put, whenever we put a number in the polynomial and we get 0, we say that number that we have put is the 0 of polynomial. Don't get confused with the language of definition. Just understand what we have done. It is simple. It is the same thing in the written form. Okay. Now, so we can say x equal to a is 0 of polynomial, or we can take this a to the left side, it becomes x minus a, and we can say x minus a is factor of px. Why factor? Because we all know factor is that number which can divide the number completely. Okay, I have given you an example. Suppose you have a polynomial px which is 2x plus 4. Suppose you have a polynomial px equal to 2x plus 4 and you are checking at p minus 2. You are checking at p minus 2 what is the remainder, and what you got is 2 into minus 2 plus 4, that is minus 4 plus 4, 0. You got 0. So you can say by putting this number you got 0. Therefore this number, this minus 2 is a 0 of this polynomial. So that is like here we can say x equal to minus 2 is a 0 of polynomial px. Or you can say, if you take minus to the left side, it becomes plus 2. So you can say this also, that x plus 2 is a factor of px. Understood? This is general notation. Okay, you will be habitual with these things. Now see. Now, factorization means just revising class 8 concepts, nothing new. In the last class also we have studied that factorization means converting from expanded form to factor form. Now you will be thinking, what is expanded form, what is factor form? Just see this example. Suppose a square plus 2ab plus b square. This term is written in front of you. This is a expanded form. Why expanded? Because you can see plus signs are coming in between these terms. Okay, so it is a expanded form. This can be written as a plus b whole square. We all know this is the factor form. Okay, or you can write this as a plus b into a plus b. Again, you can see between these two polynomials there is only a multiplication sign, so it is a factor form. Understood? Now in the last class also we studied there were four methods, that is taking common, regrouping, identity, using identities, and fourth was middle term splitting. Just to have you, just to show you one more time this method of middle term splitting, I've taken this example, that is 6x square plus 17x plus 5. Okay, we all remember first thing is to check whether the given polynomial is in standard form or not. See, x power 2 is coming first, x power 1, x power 0. So it is in standard form. Now see, this is the middle term. We want to break the middle term in two terms, that is m and n, such that sum of m and n is 17x and product of m and n is 6 5s are 30. I've written here also, we want m plus n equal to 17 and we want m into n equal to 6 5s are 30. What will we do? We will take LCM, sorry, we will prime factorize this 30 like this. 2 15s are, 3 5s are, 5 1s are. Now we will make possible pairs of these three so that we can get the value of m and n. Clearly, if I take 3 5s are 15 and 2, we can say 15 plus 2 is 70 and 15 2s are 30. Therefore, I have taken m as 15, n as 2. Now, I have written this polynomial as 6x square plus 15x plus 2x plus 5. You all remember the method? Now, what will we do? We'll take common from these two. Common is 3x. What is left? 2x plus 5. Bracket close. Plus, in these two nothing is common, so we'll take 1 as common. Left is 2x plus 5. Now you can observe these two are same. So we'll take common 2x plus 5. What is left? 3x plus 1. This is our answer. Okay. Now, in the next slide, I will be sharing with you answer key of exercise 2.3. Kindly compare your answers from that. Okay. Class, one more thing. In the last slide, which I solved the question, there was some mistake. So I have solved it here also. Everything was correct over there. Only this is the mistake. This one is 70 upon 3x. Why? Because 21 plus 49, there I have written as 80x, but actually 49 plus 21 is 70x. Okay, I hope you all have got this thing in the last slide only, but still, if not, see here. So this term is 70 upon 3x. Don't write that part, write this one. Okay, that one is wrong. So same thing, what will be I multiply in 3x to get 70 by 3x? Same procedure, it comes as 70 upon 9, sorry, my 70 upon 9. So here I will do 70 upon 9. 3 into 70 upon 9 is, we will get 70 upon 3x. And 7 7 is the 49, 490 upon 9. Again, change of sign. After that, this term will become 0. And the final answer is minus 490 upon 9. So we can say remainder not equal to 0, therefore gx is not a factor of px. Although in the question it was not said to do by long division, it was to be done by simple remainder theorem. But still, just to make you aware of these technicalities or these complexities of these questions, I have done this by method of long division. Okay, I hope you understood the method. If you want, you can solve the question by that also, which you say remainder theorem. Okay, just write this one. This is the correct one. That the previous one was wrong. Okay, these statements were wrong over there. Okay, this is solution of complete exercise. Kindly compare your answers and check. Thank you.